Welcome to yet another curve sketching example. So we're going to play around with our curve sketching once again. And this time around, I gave a little more information. So once again, we have a graph of f prime of x. And our job is to sketch a possible graph of f of x if we know that f of 0 equals 1. So it turns out there will be only one actual graph of f of x. We're just going to try to approximate that graph. So once again, we're going to do our first derivative number line and then our second derivative number line. So let's create the number line with f prime. So I'm just going to copy this graph quickly. And put it down below. So we want to figure out where, we need to figure out where f prime is equal to 0 or undefined first. So we're going to find where f prime equals 0 or undefined. Keep in mind that this is the graph of f prime. So if we're on the x-axis, this is f prime equals 0. Actually, let me just change colors. So anything on the x-axis, f prime equals 0. Anything above the x-axis, f prime is positive or greater than 0. Anything below the x-axis, f prime is negative or less than 0. So our 3 points of interest are at -2, 1, and 4. Right? So f prime equals 0 when x equals -2, 1, or 4. Then we have it's never undefined. Right? If we make our number line, -2, 1, and 4 were our points of interest. So here's x and f prime. All 3 of these places, the derivative was equal to 0. Now, if we do a little highlighting for less than 0, we're looking at anything below the x-axis. So that's going to be before -2 and then between 1 and 4. So before -2 and then between 1 and 4 are the places I just highlighted there. So this is where we're negative. We're below the x-axis for our f prime function. Then between -2 and 1 and after 4, f prime is above the x-axis, so f prime is positive. So if we draw our function f, we decrease until -2, then we increase, flatten out, decrease, flatten out, increase. Then if we look, so from here, we have, for our function, we should have relative min. So f has a relative min at both x equals -2 and x equals 4. And a relative max at x equals 1. Right? And then we know that we are, f is decreasing from negative infinity to negative 2, and from 1 to 4. And then f is increasing from negative 2 to 1, and from 4 to infinity. So that's all the information we can gather from just the sign of f prime. Next, we're going to do the number line for the second derivative. So now we're going to find the number line. Now we're going to find the number line for the second derivative of double prime. So once again, let me go ahead and paste that same graph. So again, this is our graph of f prime. So the second derivative, f double prime, is the derivative of this graph. Right. And so we're going to look at where this graph is increasing or decreasing to figure out what's happening with f double prime. So the second derivative is equal to 0, right? Where f prime flattens out, where it has slope 0. So if we look for places where the graph flattens out, we have one that looks to be around x equals 0, and then another that looks to be around x equals 2. So this is somewhere around x equals 0 and 2. The second derivative is undefined if f prime has a vertical slope. So we do in fact have one place where it looks like we have a vertical slope, and that's at x equals 1. So if we study our number line, what we're looking for, we have 0, 1, and 2 are our points of interest. And the second derivative is equal to 0 at 0 and 2, and it appears to be undefined at x equals 1. Now we're going to look for if f prime is increasing, then that means that the second derivative is positive. So if we look for where we're increasing, that happens until x equals 0, and then after x equals 2. So until x equals 0 and after x equals 2, we have f double prime is positive. If we look for f prime decreasing, that will tell us where the second derivative is negative or less than 0. So if we look for where it's decreasing, that happens between 0 and 1, and then again between 1 and 2. So our second derivative is negative between these. So now we can go ahead and look at what this tells us for our function. So if our second derivative is positive, we're happy, we're concave up. Then we're sad, concave down, happy, concave up. Or sorry, we're sad again, concave down. And then happy, concave up. So we have a point of inflection at x equals 0. We have a point of inflection at x equals 2. And then it's a little unclear what exactly is happening at x equals 1. So if we put this, list this out, we have f has points of inflection at x equals 0 and 2. Right? We are f is concave up from -infinity to 0 and from 2 to infinity. And concave down from 0 to 1 and from 1 to 2. So, but just a side note, we want to know what is happening at x equals 1. And we're just going to try to figure out what exactly is happening there. So if we draw our graph, put this all together. I'm going to go ahead and just redraw both number lines sort of on top of each other, one above the next. So if we just draw our two number lines so we can look at them next to each other. Our points of interest for the first derivative were -2, 1, and 4. And then we had points of interest at 0, 1, and 2. So we had points of interest at -2, 1, and 4. And points of interest at 0, 1, and 2. So this is x, f prime, and x and the second derivative. So the first derivative was 0 at all three of those points of interest, -2, 1, and 4. And we were negative, positive, negative, positive. Negative, positive, negative, positive. The second derivative, we were 0 undefined and then 0 at our points of interest. We were positive on the outsides, if I remember correctly. Yeah, and negative on the inside. Our function f, we were decreasing, increasing, decreasing, increasing. And our function f prime, where concave, or second derivative tells us f is concave up, concave down, concave down, concave up. So we again had min at -2, max at 1, min at 4. And then we had points of inflection at 0 and 2. And then something going on at 1.
Would you like a snack though? Would you like some Cheerios? Cheerios?
So if we draw our graph, we were told that f of 0, I believe, was 1 in the original problem statement. Yeah, f of 0 was equal to 1. So we can go ahead and put, oops, we can go ahead and put that at f of 0 we're 1. And then we had points of interest at -2. So we're crossing at x equals 0, y equals 1. We have a relative minimum at, oops. We have a relative minimum at -2, and then a point of inflection at 0. So somewhere in here, we're going to have a relative minimum at -2. We have our concave up. And then at 0, we're going to switch to concave down. And then again, we're going at x equals 1, we're hitting a max. And then we'll come back down. We have another point of inflection at x equals 2. And then we have a relative minimum at 4. At this point, it's a little unclear precisely what is going on at x equals 1. At first derivative is defined. It is equal to 0. The second derivative, we get something undefined. So it's a little unclear precisely what is happening at that value. But we presumably will look something like this. All right. So this is just graphing based off of the graph of the f prime, figuring out what f would look like.